Sometimes folks will use multiple EIGRP autonomous systems as a scaling technique. Now, the rationale that is behind this is that they're going to limit the scope of queries to a single EIGRP autonomous system, but there's actually some issues that we run into with this. So here's an example of a topology that's got external route redistribution from RIP into EIGRP AS200, and then that's being propagated throughout the network. So router C in this example here is going to have a peering relationship via EIGRP with router A as well as with router C. So since they have these peering relationships, whenever this redistributed route comes in from RIP, it's going to be advertised to router A and to router B. Now in this example, router A is sitting on the border of two different EIGRP autonomous systems. Now, AS200 is where that external route comes in. It is then going to be redistributed into AS100. So we've got to do a redistribution process and bring that into AS100. And then we're going to pass that over to router B. So router B has learned that prefix, the RIP route. He's learned it in AS200 from router C, as well as AS100 from router A. Now, when we have the same route learned through different routing processes, the route that is installed first is going to be preferred. So perhaps we prefer on B the route through AS200 because we got it before router A had the opportunity to do any redistribution. So that's what it looks like passing these routes around. So just to recap on this, we have a route that's redistributed from RIP into AS200. Router A redistributes it into AS100. Router B gets that route from both 100 and 200. Again, the same route. The one that we learned first is the one that's going to be installed and preferred. Let's say that a route that was redistributed from RIP into AS200 is lost. So router C sends a query to router A. Now, what is router A going to do? Well, router A has to query all of its neighbors, and that's what's happening here. So it queries its neighbors, which include its neighbor in AS100, which is router B here. Now, router A replies for AS200, and router A sends a query in AS100. Now, if the timing's right, then B has already received a query, sent a reply back, and it already knows that it doesn't have an alternate path. So when A queries B, it replies back and says, no, I don't have another path. So what's actually going on here is that the query from router C can be answered by router A quickly, but A still has to wait for a response from B, so A is in active mode. We didn't really scope the query process. Well, we kind of did, but really it doesn't stop the queries from being propagated by having more than one autonomous system. What it did is it made us wait a little bit longer for A to be fully converged. So really what we want to do is, if we want to contain our queries, we want to do things like summarization, distribution lists, and stub networks. Because the query, again, in this case wasn't stopped, it just got delayed. But we can stop those queries. We can really, truly scope them by using those techniques just mentioned, summarization, distribution lists, stub networks.